Okay, sometimes we want to be a little bit more precise. Drawing isn't good enough, so we need to add these vectors mathematically. Okay, so my example here is going to be 23 meters per second at an angle of 57 degrees plus 5 meters a second at an angle of 132 degrees. Now, when I tell you to do something, I need you to pause this video and actually do it, okay, because I have the answers written out, but I'm going to need you to try to do this on your own, and then you can double check your answers, okay? So when we add vectors mathematically, it is a 3-step process. The very first step is we are going to break the vectors into their x and y components. Okay, so here's what I mean. Let's look at our first vector here. This vector is going off at an angle of 57 degrees, okay, something vaguely like that, okay? So it's 23 meters a second at an angle of 57 degrees. When I say break it up into our x and y component, I want to know how far over in the x direction does it go, and how far up in the y direction does it go. Now, we're going to need some trig here. Great thing about this, guys, I got the trig for you. Okay, so x component of our vector is going to be the magnitude of our vector times the cosine of the angle. And this because cosine is adjacent, right? SOHCAHTOA, okay? The y component of our vector, y equals the magnitude of our vector times the sine of our angle, okay? Again, it's really important that we're in degree mode here, okay? So for both of these vectors, I want you to pause this video, okay? Find the x component and the y component of each, okay? So we can pause and figure those out. Okay, now you have a bunch of numbers and it's kind of hard to keep track. So I'm gonna help us do this, keep track by making a little chart. We're gonna make an x chart column, a y column. Okay, I'm gonna call this vector 1. Doesn't really matter which one vector 1 is. I'm gonna call this vector 2. Okay, and we're just gonna write the x and y components in here. So for vector 1, my x component, if we do 23 cosine theta, you should get 12.53 meters per second. And our y component is 19.29 meters per second. And that unit just comes from that very first number. And if we look at our second vector is in quadrant 3. So we are going to have a negative x component. That's fine. So it's negative 3.35 meters per second. And our y component is 3.72 meters per second. Okay. But that right there is breaking them up into the x and y component. That's step 1. Okay. Step 2. You're going to find the total x and y. So what I'm saying is if I were to add these up, this is how overall it goes over in the x direction and how it goes over in the y direction. So you're just going to make another row. And you're literally just going to add up the columns. So 12.53 plus negative 3.35, you get 9.18 meters per second. Y, if we add them up, we get 23.01 meters per second. Okay, so that's step 2. Step 3, you're going to find the resultants. Okay, here's how we're going to do that. We're going to first start by just drawing an axis, okay? We're going to draw this out, okay? So if my total is 9.18 in the x, I go over 9.18 in the x. My total y is 23.01 meters per second. We're going to just draw it out. Then my resultant, okay, is going to look something like this. Now we need to find a value for this resultant. And here's what we're going to do. We're going to use the Pythagorean theorem. A squared plus b squared equals c squared, where c is what we're looking for. So we're looking for the square root of a squared plus b squared. Okay, so c equals the square root of 9.18 squared plus 23.01 squared. Get that number. You should get 24.77 meters per second. Okay, now we're not done. We need to find an angle. We need to find this theta, okay? And here's what we're gonna do. We're gonna use tangent again, okay? And I'm gonna say the angle equals the inverse tangent of the absolute value of your y total divided by your x total. Now, the absolute value is important, not for this one, but we'll get to it, okay? So you're gonna plug in theta equals inverse tangent of 23.01 over 9.18. So theta equals 68.25 degrees. So my final answer is 24.77 meters per second at an angle of 68.25 degrees. Okay, that is my total when I add up these two vectors. Okay. Okay, let's do another one. Okay, again, I want you to pause this and actually find these components by yourself. But let's say I'm adding up 42 meters per second squared at an angle of 120 degrees plus 16 meters per second squared at an angle of 160 degrees. So again, pause your video and I want you to actually find your x and y components of each of them. Okay, so pause and make your chart. Okay, so again, here's what you should have gotten. Okay, and I'm just going through this quickly, but here are the numbers if you find the x component of each vector and then the y component of each vector. Don't forget those units. You know that I'm gonna actually really care about those units, so make sure you know those, get those units right. Okay. So your total x and y is negative 36.04 meters per second squared, and your total y is 41.84 meters per second squared. Now I'm gonna just draw this out really quickly, okay? I don't know why that's not making a straight line, there we go. Okay, so negative x doesn't go to the right, negative x actually goes to the left, so I'm gonna draw that one in first. Okay, so negative 36.04 meters per second squared. Okay, now a positive y value can go up positively. Positive is up, so 41.84 meters per second squared. So let's just pause and think for a second. What quadrant am I in here? I'm no longer in quadrant 1, I'm in quadrant 2. Meaning if we go back to that very first video, and we say, here are my angle measurements. Okay, just kind of keep that in the back of your head for now. Okay, so again, I want you to use the Pythagorean theorem. And I want you to use theta equals inverse tangent, the absolute value of y over x. Here's where that absolute value comes in handy. Okay, and I want you to pause. And I want you to find the value, okay, what happens when we get there. Okay, so C, you get a value of 55.22 meters per second squared. And theta, you get a value of 49.23 meters. Excuse me, 20.23 degrees. Now here's the issue. If you tell me you're going off in a direction of 49 degrees, I think you're going up and to the right. Okay, we found this angle right here. We don't want that angle right here. We want this angle right here. So what are we gonna have to do? We're gonna have to do 180 minus our angle. So go ahead and plug that in. And then our final answer is gonna be 55.22 meters per second squared at an angle of 130.77 degrees. Okay, I'm gonna give you a little cheat sheet. depending on the quadrant you're in. And the quadrant you're in is going to depend on your total x and y. Okay. So if you're in quadrant 1, okay, you don't have to do anything to your angle. Whatever you get for theta is going to be the right answer. Okay. If you're in quadrant 2, what you're going to do is you're going to do 180 degrees minus your angle. Okay. If you're in quadrant 3, you're going to do 180 degrees plus theta. And if you're in quadrant 4, you're going to do 360 minus theta to get your final answer, to make sure you're in that correct quadrant.